Hello and welcome. This is Professor Bear here to talk to you today about string processing. So let me share my screen with you and let's get started. In our last meeting, we have been talking about how to do flow control. We've talked about using if statements and while statements and for statements in order to loop over various things. And so what we haven't done is we haven't combined using flow control with strings. So part of what we'll be doing today is reviewing what we've already learned about the strings, and then we will be talking about how we can combine information about the flow control with processing the strings, that is moving over a string one position at a time, and then based on what content is at that particular position, we may wish to take an action. So for example, maybe changing lowercase to uppercase letters, or doing some sort of an interesting action using if statements or while statements based on what is actually there. All right, so just waiting for this to pop on over so you will be able to see the slides. As usual, you can always grab your slides off of the Moodle site. All right, there we are. I think we are good to go. All right, so sorry, these slides are a little slow in flipping today. Okay, very good. Come on. All right, let's see. Yeah. This really is the second slide. Okay, and before we get into that, I am recording this this slideshow ahead of time for you for this semester, so do bear with us as we may need to make some updates as we move through the semester. But at this point, when we're on the string weeks, we should be 1 week out till the exam. So in our planning, we'll have a review the week after, and we would have our exam online the following Thursday. So as far as I know, that's going to be our setup. Notice that you'll have a homework 5 assigned, so that will cover strings, and strings will be on the exam. However, we're going to give you some extra time to get that turned in. So usually what I do is I make some solutions available to those who turn this assignment in ahead of time. So if you wish to complete the assignment and turn it in for credit before the exam, you would be able to have a look at the solutions. But if you prefer to focus on studying for the exam, you would have that extra time to do your homework. So that's usually what we do about that, and that's what I'm planning to do this semester. You'll all have your exam online regardless of when your lab is, so do notice that it will be at the 8 o'clock to 9:20 time, and the exam will be passed out to you through the website, and then what you'll need to do is take that and complete it by 9:20 and turn it in. Obviously, there will not be labs that day. You also have your proposal worksheet due for discussion in our lists lab, which is again 2 weeks out. So you should just have this in mind. So one of the things I'm going to do with you today is give you some ideas on what you might be doing for your project. And as a reminder, if you have an academic accommodation letter, you need to please get that to us, because we can't give you your accommodation if you do not provide your information. So let me just give you some ideas about what you might want to do for your final project. Your final project is in lieu of an exam, so it is worth an equal amount of how much our exams are worth, that is 25% a piece. So you want to make sure that you pick something that's reasonably substantive to do. This is your opportunity to showcase what you've learned about Python and the extent to which you have mastered the skills that we've taught you in this course. That being said, there are a number of ways that you can do that, and the number of projects we get is as diverse as the students who take the class. And I do really encourage you to select a project that you're going to enjoy working on and that is meaningful to you. You might take into mind what are the reasons why you decided to take this course. Do you have some particular applications that you wish to do with Python programming. Is there a way that you could write a program that would be meaningful for yourself or for others? Or what would be something that would just be fun and entertaining to work on? All of those are different things that motivate people's reasons for choosing the project that they do. Sometimes under these circumstances, people feel that it's useful to pick a project that's reasonably well defined, and so may want to choose perhaps some of the game projects and these kinds of things where it's pretty straightforward what the steps are in order to complete the project. Of course, we're looking for original code, and I'm well aware that there are many of these types of projects that are available online, so we would need to make sure that you are having your own unique solution, and that what you're turning in is going to be your solution, and we're not just using the information that's on the web. Can you use information from other sources? Yes, absolutely, you can incorporate aspects beyond what we have done in the course, but we are looking for demonstration of mastery of what we've learned in the course, and that's what I'm going to be looking for in your project. And when we discuss your project, I will be looking for that level of understanding and knowing how you put your project together and how you did this, which will be some of the major determining factors in what grade you're going to get on it. So there are many things you could pick. Usually students really enjoy doing their project, and I think the more interesting project you pick for yourself, the better off it's going to be. You'll probably end up spending, a lot of time on working on it, so you might as well have it be something you really like. So games, like I mentioned, are always a very popular choice. We always have a great selection of games that have gotten coded up. Oftentimes students are using the turtles as the graphics interface, so we'll be learning about turtles in the upcoming week. That's the official assignment for the week of the exam instead of having a lab. So you'll be working on that officially on Tuesday. But that will be a really great opportunity for you to learn a little bit about how you could add graphics in, and usually that's a really fun and popular lab to do. One of the reasons being because you can use that then to do your game. So what are some of the games we have had? We've had Battleship, Blackjack. We had chess attempted a couple of times. Usually that's had to end up being a more simplified version, but we have had it. Choose Your Own Adventure is a popular thing to do. Crazy 8 card games. Card games are always really popular. Data encryption, we had an excellent project on that. Dominoes, Dr. Nims, which is a sort of like a question and answer kind of game with some like trick question and puzzle kinds of things. Hangman is one of our standbys. We had an adventure game themed on Harry Potter. Mad Libs, a maze generator. That was actually a very challenging project because the maze actually got generated by the code. We've had Pac-Man, several versions of Snake, Sudoku puzzles. That actually is a little bit tough because the puzzles were actually generated by the code. Tic-tac-toe is one of those standard standbys that we always have. Who Wants to Be a Millionaire has been done a couple of times. Word Scramble, where you get some letters and the player has to guess some words, and the computer works out how many possible solutions there are. We had Yahtzee. We've had all kinds of different fortune tellers and that sort of thing. So that's some of the games that people sometimes enjoy. Think about what games you might have enjoyed playing as a child that might inspire you for something that you might want to do. Those of you who are involved in music and arts, we've had a Broadway show suggestions and maps. So the student had a map as an image in the background in Turtles and would provide directions on how to get to the show you were going to go to, in addition to generating some show suggestions based on a questionnaire. Chord progression and auto composition is something we've had a couple of students do. So if you know something about music theory, that might be something interesting. We had a clickable Turtles coloring book, which was really neat. A face maker that would draw your face based on some inputs. Guitar tab transposition was another one. Harmony composer, which is similar to the chord progression in terms of the underlying information. I had a student who was planning to start a business She was a graduating senior, and she made a makeup suggestion to go along with her business. Scale transposition, sign design, so that would design this sign based on some input text. And we also had song lyric analysis. Maybe you are in the course because you're interested in applying your knowledge to the science areas. So some suggestions from physical and life sciences are animation of planetary motions, popular among our astronomers. Automated analysis of lab data is always a useful thing. We have some plotting that we could help you with if that's something you want to do. The central dogma of biology, DNA makes RNA makes protein, is the standard project that is done in a companion class to this one, the biology version of this, taught by my colleague, Professor Michael Weir, and that's the project that everybody does there. So we sometimes get students who want to do this project. Curve fitting is useful for many of the sciences and some of the social sciences, economics. So people who are interested in this sort of thing and they have some data out may wish to work through how you could make predictions in the future based on some curve, and that's the typical thing. Database analysis is something that's done that oftentimes requires a little bit more than what we're able to cover in this course. And you may wish to bring in some libraries, some additional libraries, which is fine for one of your 3 goals. And then you would write some code around actually processing what you pulled out of the database, maybe graphing or that sort of thing. Neuroscience study guide, a question and answer kind of thing. Progression, processing of data in a CSV file was another useful one. And Python programming of PyMol, so that's a molecular viewing software, and you can actually write Python code because that is actually it is actually a Python interpreter. So you can do all the things you do in idle in PyMol and also program it up so that it displays molecules. From the social sciences and economics, some useful or some great project ideas we've had themed along this. We've had environmental learning, so a student had spent a semester abroad and was very interested in saving the environment, so it was a sort of like clickable information thing made in Turtles, and then there were some questionnaires and like quiz kind of things to make sure people were learning about their carbon footprint in the environment and this kind of thing. So it was a really nice suite of educational programs that was her project. We've also had a mental health screen where a variety of questions is asked, and then it screens the person for whether or not they need some mental health. So this was by a student who was working for an internship, working in a hospital kind of a setting, a clinical setting of some sort. So I think they may have actually been using that, so that was very nice. Similar kinds of things to the health screen. We've had a variety of psychology questionnaires and data analysis and graphing kinds of things, which is kind of like focused on automating patient intake and that sort of thing, where there would be a need for some kind of questionnaire and then deciding what to do based on the answers that the patient provided. From economics, we've had many kinds of different data visualization. We've had a very nice web scraping project, actually a couple of those. Beautiful Soup is a tool that can expand the Python usage, and that was used to collect some data from the web and then do graphing and analysis. So this can be useful because there are actually some libraries specific for economics, and we've had some students who wish to explore that. And again, the curve fitting is very popular among the economics students because there is a lot of this idea about fitting the data and then projecting what will happen in the future. And curve fitting is entirely appropriate for a project like that. Some additional ideas. We sometimes have students who are interested in language and culture, and we've had a number of excellent translators. We've had a variety of different languages, including Greek, French, and some others that aren't listed here is Spanish and many other languages as well. Mandarin character writers, so this would actually draw the characters. It was like an educational tool to teach people how to write the Mandarin Chinese characters. We have also had a very nice recipe suggestion where the program would prompt the user about, you know, the kind of meal and maybe dietary restrictions and that sort of thing. And based on that, would recommend some kind of recipe that they should use for the meal that they were preparing. And then we have this category Pie Surprise, which is kind of just like, and now for something totally different. We've had alarm clock music player. So a student, in fact, actually set it up so that you could say what time you want the alarm, and then it would pull and play a music file that was on the disk, like on that computer at that particular time. We had appointment maker calendar. So think of like Google Calendar. So somebody made their own version of the Google Calendars, and all kinds of different tools for study notes and quiz generator type things, where you would have a subject of interest and it would generate some questions based on the storage of the information into some particular format, and then generate some questions for the quiz for studying purposes. So very nice project. So as you can see, there is a very wide variety of possible things you could do. And of course, at this point, I've seen quite a lot of projects. And so one of the things that we need to do is to make sure that everybody is set up to do a project that is, number one, sufficiently detailed to demonstrate your mastery of Python in the course. So we want everybody to choose a project that they'll be able to get a good grade on it and do well with, and also representative of your skill set from this course. And also we want to make sure that we all, from the other side, choose a project that's reasonably doable. Sometimes it's a little bit difficult to gauge what is going to be entailed in actually completing your project. And so part of what we are going to be working on throughout the rest of the semester is iteratively refining what it is that you are working on. And this is why we have multiple check-ins and so forth. And the proposal worksheet is really the first of that. So what we're asking you to do is to share the ideas that you think you have. Now, I realize we haven't actually done the second half of the course yet, so you're not always going to know what it is else that you want to include in your project, but I think that it's important to get the process started, and we really want to do that at this point in the course. So what I'm asking you to put together is a very simple worksheet. We need your name, section, and what is the topic of your project? What are you thinking about working on? So I've provided you with a sample worksheet, and you'll actually get basically this sheet to fill out and to share back with me. And so then what you want to do, and you want to think about 3 areas of focus or 3 goals for your project. And like I'm saying, these may change over the course of the semester, but we want you to start with something so we have an idea of where you're going with this. So some other things that you're going to have in here are going to be very basic in terms of, like, yes, we're going to be using flow control variables and these kinds of things. And basically everybody's project should have some of the components that we've used up to this point. Then you also want to think about, okay, looking ahead to the skills that we're going to learn in the second half of the course. What am I planning to use? So the things that we're going to have available are going to be lists, which is going to be somewhat similar to the string processing that we're going to talk about today, but instead lists will allow you to, as it suggests, have a list of items. Then you would process over the items, whereas today we'll talk about processing over characters. So you may have lists. We'll also talk about dictionaries, which is a way of storing things that are mapped together, pairs of things. And then we'll also talk about file input and output, which is applicable to many projects. You may wish to have some data stored in an external file. That would be file input and output. And finally, we talk about object-oriented programming. So you may wish to incorporate some aspect of object-oriented programming into your design. So what are you planning to use? What would be appropriate for the kind of a project you're looking to do? And then you'll need a third area of focus. So oftentimes students may wish to have a graphical interface. So using turtles is a very popular option. you may instead not be interested in the graphics, and that's fine. You may instead be interested in the designing of the actual code in more detail. You may use maybe say like file input and output and a complex use of object-oriented programming, which is a perfectly fine project for you to do. So part of the conversation will be working out your ideas and me providing you with some suggestions on how you might go about that. Oftentimes there will be some projects that I've seen in the past that I may be able to draw upon to suggest some ways that others have completed similar projects, or perhaps draw upon others' projects that may just offer some useful suggestions for you. All right, so be thinking about that, and I definitely am looking forward to seeing what you have to say on your worksheets. So let's take a bird's eye view of what we're going to talk about for strings today. First, we're going to begin with recalling information on strings from the previous lectures. We'll talk about some built-in string functions that you can use to process the strings. We will talk about the index operator, which is a pointer going over the strings, and then related to that is the slice operator, which can pull out a piece of the string, can slice out a chunk. While can be used to iterate over strings using while loops based on what we talked about last week. This will be an extension of that. We may want to compare strings. We can use the in operator to check for a substring. That is, do you have a particular letter pattern, a word within a word kind of a thing, to see if we can find that in the string. We also have for loops to iterate over strings. And finally, we would like to integrate the skills we have with the strings involving flow control and functions to write programs to process strings. So those are our goals for this. And I'll mention also that this is the last content which will be on your first exam. So let us do a quick review of strings of what we've seen so far. So what is a string? It is a sequence of characters, and we know to enclose them in the quotes. So here are some examples of some strings. Are any of these not valid strings? Can you pick out any problems here? So hopefully you have noticed that there is a problem right here, that we have a second single apostrophe. So what should be done in this case is we should be using the double quotes. All of the others are fine, and it is definitely possible to represent numbers as strings if you wish to do so. Some of the things we know how to do with strings are to print them, and I'm showing you just some simple statements here that are representative of those things that we know how to do with them. We have also used input, right? So we can get the input using the input function. Here is a string that prompts the user, and the input function will return out a string which can be stored in a variable, in this case, big lake. And so then once we have that information, we can use that in subsequent programming. We've also talked about coercion to convert numeric values to a string. So it would be possible to get some input, and as we know, that input will be in the string type, and so we may wish to convert the format between numeric formats such as integers and floats with the string, which is possible to do using coercion. We've also learned how to concatenate strings using the plus. So here is an example of concatenating various things together. Again, notice that the reason why this Green Bay Packers actually has spaces between these because they're explicitly included between inside the quotes, whereas if you combine things together using the comma, such as in a print statement, there will be a space automatically put there, but plus does not do that. We also know how to repeat them using the star. So here is an example of a cheer. So we're going to multiply by 3, which means it's going to increase whatever is in here that number of times. So here we have a cheer chant. We may wish to compare for equality and for inequality, so we can ask, are these two things the same or not? And they are definitely not the same. So we get false. So that's what we've done so far. There are also so many useful things that we can do using the functions that are provided by Python to process the strings. So the first one is the length function. The length function returns the number of characters in a string. It has alphanumeric characters, spaces, and punctuations all do count as characters. So sometimes people get confused about spaces and they think, oh, well, it's not going to count. It counts, okay? It's just however many characters, be it whatever character it is. The quote marking the string, however, do not count. So the length of the empty string is represented by 0. So this is the syntax that we're going to use. We type length and then we give it some string to check. We may also put an expression in here that evaluates to a string that would then report back what the length of that is. So here is a question about what is the length of this string here, 1, 2, 3, 4, 5, and so the length, of course, is 5. Now, in this case, we're illustrating what is going to be included in here. So we have some punctuations and some spaces in here, and they are all, in fact, included in figuring out how long it is. And this is the empty string, which the length of is 0. Now, just notice that in Python, it can be difficult to tell whether these quotes are the empty quotes or if it's intended for there to be a space in here. So I do try to always just put a note next to this empty string. This is something to keep in mind as you're thinking about your exams on how to make that really clear on your test, whether or not you intend for there to be a space or not, and I will do the same for you on the questions. Some general string methods syntax. If we're going to use the built-in methods, and so a method is like a function, but it pertains to a particular object. And so some of these are specifically are actually methods. We don't need to worry so much about whether it's a method or a function for the moment, but it is important to get the general syntax because a number of these basically just follow the same type of syntax. So what we're going to do is we're going to have some variable, and then we're going to have some string function, and then we're going to have the empty parentheses. So it's a little bit unusual because this is basically going to be the input, and then this says that there's no input here. So suppose we wanted to use the uppercase method for strings, and so we would call that upper by using the upper keyword. And notice that it doesn't turn color quite the way that the others do. And this is because technically it's a method, which means the coding of it is slightly different than some of the other keywords because it is, well, when we do object-oriented programming, it will become more apparent what exactly this means, but it's a function associated to a particular type is what it is. So here is some string s is equal to Huron. And so if we want to convert this to uppercase, we use our variable name, so s, the dot notation to indicate now we're going to call the method. And here is the upper method, and this method is not taking any input because the input is this variable over here. So it is going to evaluate whatever this is, so to find the value of s, which is Huron, and converts it to uppercase letters, which is then what we get right over here. So s is the string, Huron, upper is a string method, and this function returns the input string s and the uppercase letters, which we see here happening interactively. Of course, if you're going to be doing this in the script, you would want a variable equals that if you wanted to use it for something else, just like any other function. String methods return Booleans. There are a number of this type, and so the different ones are is digit, is alpha, is lower, and is upper. They're easy to remember because they all start with is, and it's useful to think of them as asking the question, is this a digit? Is this an alphabetic character? Is this lowercase? Is it uppercase? It's going to return true if all characters of a non-empty string are numerical characters. So here we see we have 1, 2, 3 dot is digit. Notice that we are using this dot notation that I introduced to you a couple slides back, and so it's basically following that format. And we can see that this 1, 2, 3 is a digit, which returns true, but ABC is not, so it's going to return false. We also have a check for the alphabetic characters, so 1, 2, 3 is going to return false, but ABC will return true. We can also ask if something is in lower or uppercase. And so this is true, that this is in the lowercase, and this you see that some is true that it is lowercase, but not all. So overall it will be false. Then we have the similar thing for the uppercase letters to check for uppercase. We also have some additional more string methods. Upper is going to return the alphabetic characters in the uppercase. So unlike is upper, which asks the question, is it in uppercase? Upper is like the coercion functions. It says, make it into uppercase. So again, we're using our similar dot notation where we have the variable or the whatever your string is, dot upper, and it will convert it into uppercase letters. Notice that it will in fact actually take something that has non-alphabetic characters, so Route 66, a famous road in Chicago to LA. This upper will convert the letter component of it, and it will just leave the numbers alone. And similarly, we can convert things into lowercase, so E. Cummings is a famous poet that wrote in lowercase, and we can convert this information into lowercase, and again it leaves the spaces and the numeric values alone. This brings us to string indexing. So the string indexing is a kind of an operator, just like many of these other functions that we've been talking about. The index operator looks up a character or characters in a string. The index operator is the square bracket. So they may look like innocent little parentheses, but actually they're not. They are actually doing a task. So when you put something in the brackets, it will actually make a selection. So an index is used to specify which character or characters in the string you would like to extract. The indices may be positive, negative, or 0. We can specify a range to select more than one character. A string can be considered by its characters and then can be indexed in the forward, positive, or negative, backward direction. So here is an example of a string. We have Michigan here, which I've split out into the individual letters, and so we can number these positions in the forward direction or in the reverse direction. Notice that the numbering begins with 0 to indicate that the index of the first position is in fact 0. And here in the reverse direction, there is no 0 of the characters because of course we have only 1 0 and there's no positive and negative 0. So we begin with -1 up here and we go back to -8. So when we are selecting our position numbers, we are going to make use of these in order to do that selection. A string can be considered by the characters, and then we're going to index it. Indices greater than or equal to 0 begin at the left until they offset from that point, whereas indices less than 0 indicate offsets from the right and from the right end of the string. So forward indexing begins with 0 and runs up to the length of s minus 1. So notice that there are in fact 8 positions here starting with 1, but because it starts at 0, it will go up to 7. So the length of this would be 8, but the maximum index is going to be the length of the string minus 1. In the reverse direction, it's going to be equal to the negative of the length of the string, right? So it'll start at -1, it will go down to the length of the string. So there is a little bit of a difference. And of course, just to point out, in case this wasn't obvious, a particular position may be indexed by more than one number. So for example, this C right here can be indexed using the positive index 2, but it could also be indexed using the negative index 6. So we have these double indices, and it can be useful because there may be cases when you want to index in the positive direction or in the negative direction, and that's available. So let's take a look at some examples of how this actually works. This is probably the easiest way to understand this. So string indexing, we have the syntax, we would have the string, and then we would have the index that we're going to use with this. So for example, if we have the string Michigan of 0, what this is going to do is it's going to pull out the 0th item in Michigan. So it will pull out M, and so on. We can do this all the way up through the positive 7th character. We can also index it in the reverse direction. So this is emphasizing the idea that there is more than one numeric thing that you could slice out that will pull out the same character. So let us do a brief exercise just to check and make sure you understand what's happening. All right, so here we have the question now, what animal was used to haul barges along the Erie Canal? So it's like one of those secret messages. So now what you should do is see if you can do this, do these slices to answer that question. All right, so here we have the decoded answer. This comes out to be mule. We are pulling the positions from the names of the string, so it's important that you select the correct string and then go to that letter. And we have a couple of positive indices and a couple of reverse indices. We can also have index bounds. So thus we see that in order to be a valid index for a string, that there are certain criteria that must be met. A non-negative integer I must satisfy 0 is less than or equal to I, and I is less than the length of the string. That's because indexing starts at 0 and goes up to the end, so that the bound on that end is going to be 1 less than the length. So if you go outside the bound, you see what will happen is you will get an error. So this is what the range is available on the positive I. A negative integer j must satisfy negative length of string is less than or equal to j, and j is less than 0. So for example, here is our string 2 here on again, and we can have s of -1, -5, but you see that -6 is going to be outside of the bounds. In addition, we also have the slice operator, which looks very similar to what we've just been doing. The way you recognize a slice operator is that it has a colon in it, and what this is going to do is this is going to slice out a range of positions. So the numbering will work exactly the same, but it's just that we're going to be taking more than one position. So the slice operator is going to return a substring. That is a piece of the string, but it may be more than one character of a string between two indices. The slice operator is these square brackets and it includes the colon. The colon is used to separate the start and the stop indices. So it will go from whatever is specified here up to whatever is specified here, but not including this one. The slice begins inclusive of the lower index and it goes up to, but does not include the upper index, which is what we are saying right here. So we can look at that in this syntax, the string, and then we have the square brackets. Here's the colon, start index, and stop index. So let's just take a look at an example. Here is Michigan again, and we have our same numbering as we've seen before. Now this little indicator I've put underneath here hopefully is useful to you to understand what it is I'm trying to represent here. So if you've ever done those number lines representation of domains and ranges in math class, I'm trying to follow that notation. So if it's a filled circle, it means that it includes this value, and then I have used the arrow to indicate it goes up to but does not include that position as a visual representation for you. So for example, if we take the slice of 0 to 2 on Michigan, we are going to have the inclusion of M and I, and it goes up to but does not include position 2. So we get just MI. Here are some more examples. So this string of 0 up to the length of the string is going to specify as the trivial case of the entire string. So you see that length of S will go beyond the length of the string, but because we go up to but not including it, it will stop at the 7th position, which is exactly what we want to incorporate the entire string. If the index is equal to the stop index, when start and stop are the same, then the substring will be empty. So here we have start at 2 and include 2, but go up to and don't include 2. What will happen? It's kind of a contradictory situation. So that will return the empty string. If the stop index is equal to the start index plus 1, then basically we are going to pull out a single character. So in that case, the S of start index up to the stop index is equal to the start S of just the start index. So we're illustrating that here. We would go from M up to but not including I would be the same as taking the slice of 0. Here are some more examples. So suppose we want the slicing beyond the length of the string. What is going to happen? You might expect that it's going to cause an error, but in fact what it does is it's just going to default to the length of the string that's available. So obviously there's not 100 positions in Michigan, so it will just return regular just Michigan up to the last character. If the start index is further right than the stop index, then the empty string is returned. And this is something that always is a little bit confusing to people, because if you go slice of 7 to 0, okay, so now do you see that we're moving from the right to the left? It's backwards. And so you might expect that it would somehow return this slice, or maybe return the reverse slice or something like that. That's not what's going to happen. What's going to happen is it's going to return the empty string because it's going backwards. So you're actually not growing in anything. So you always have to move from the left to the right to grow something in. And if you're going in the reverse direction, it's just the empty string. And that works whether or not you're indexing it using the positive or the negative indices, or even the mixed ones. And some of that is illustrated here. So what we're showing here is you can, in fact, use the negative indices. So you can do slice of -7 to -4, which works because you see we're moving from the left to the right. And so that does give us a slice. But, well, we can also do a mix between positive and negative indices. So we're moving from -5 to +5. And so we see that we're moving from the left to the right. And so it's up to including this position. So we get high out of this because G is excluded being on the end. Another concept useful for working with the slicing is the implied indices. That means that if you do not specify the beginning or the end, it's assumed to be the beginning or the end of your string. So here we have a slice from nothing specified up to 4. So this just says start at the beginning and go up to but not including the 4th position. If the stop index is omitted, similarly, it will proceed to the end of the string. Here we see the stop index is omitted. If you have no indices specified, both the beginning and the end will be specified, and this is basically going to simply be equal to what the string is. So then, one of the most useful things we can do with strings is iterate over them, and this connects with the looping that we've talked about last week. So this idea is known as string processing. One can combine iteration with indexing to process a string. To do this, we would typically use a while loop. So what we can do then is write a function that would process over a loop. Here's an example. Definition of loop my string, and here is the input S for string. Here's our signature. We're going to take a string for an input, and nothing is getting returned. So the return type will be none type. So we're going to print the answer to the screen because we don't need to do anything with it other than view it. This is an important concept, initialization of the counter. This here means that we're going to have some index I, which is going to be our pointer as we move over the loop. So we set I equals 0 because we'll need to start somewhere. Now here we say, well, I is less than the length of the string. So you see that I will proceed until it reaches the length of the string, which means I will then point to each position. That's the idea. And the reason why the I increments is because of this line right here. This is the augmented assignment that we saw last time, and this will increment the I. It is very important to remember that when you have a while loop, you will need to include also the I plus equals 1 part, because this is what will advance the loop. What is it actually doing? Well, it's going to print each position. So we are going to loop over the string, and we are going to print each position out. When this is done, what will happen is the length, the I will start at 0 and then it will increment. So I will go up to 1. So I'm thinking about the variable table. I will go to 2. And then when I gets to the length of the string, so here we're showing it for the ABC example, what will happen is that this statement will no longer be true and therefore will become false. And then the function will stop the execution of the while loop and go to the return statement, because that's what's next. And that will then return none type. So what this is going to do then is it will print each character in turn. Here we have our ABC being printed from our ABC input. Spot the bugs. All right, this is a great example. I would challenge you to pause the video and try this out. Here we have a function called count S in a river name. So our signature here is an input string and we're asking it to output an integer. It's going to count the times the letter S lowercase or S uppercase appears in a river name. This version may have bugs. So take a look at this. It may look like it's working, but take a closer look and see what you can find in here. So consider the output from Mississippi and assign two famous rivers. What problem or problems does the code have, and what can you do to help debug the code? So we've learned a few tips and tricks on how you can improve the code. What could you do about that? Rewrite the working version of the code. All right, so go ahead and take a moment to work on this, and we'll be back in a moment. All right, well, thank you so much. I hope you've enjoyed looking through that problem and testing your knowledge. Let's see how sharp you have been in spotting the various problems with this. So this code actually has quite a few bugs. Okay, so initialization. It's important that you initialize your count, your index. So notice that I is going to be the index over the while loop. Do you have to pick I? No, you could pick any variable name. It's really not important what you pick. But generally speaking, we like to pick I because it kind of makes sense to have I for index. Notice that here in the original code, I started at 1, but if you're going to process over a string, we need to start at 0 because the numbering of strings starts at position 0. All right, the next problem we have down here is you must increment the index to cycle over the river. So if you do not include the I equals I plus 1 or I plus equals 1 for the shorthand, what's going to happen is your loop is not going to move forward, right? Your I will be on position 0 and it would never advance. And notice that this one does not increment I. This one increments the counts, but it does not increment I. So we will only process position 0 infinitely in this example. Okay, and also we have this other issue here. We need to deal with the conversion of the letters between upper and lowercase. And there's a couple of different ways you could tackle this. You could, for example, change everything to uppercase. But what is being shown here is converting everything to lowercase so that we know whether or not to count it. You could have also solved it using an OR statement. So you could have said if river of I dot lower equals the lowercase s, or river of I dot is, well, you could have not used the dot lower. So you could do if river of I equals s, or if river of I equals capital S, right? So you could do it like that. But this is probably the better of the two approaches, to use either the dot upper or the dot lower. So converting all letters to the lowercase makes the count case invariant, which was part of what was being asked for you to do to make sure that it will count either capital or lowercase letters. So then when we run this revised code, we get the correct output. Next, let's talk about string comparisons. This is asking the question if two things are equal or not. And there are a couple of things we need to be aware of about how to do this. So to start off with, the comparison operators, less than or equal to, greater than, equal to, equals, and not equals are overloaded to compare strings. Now, why do we say this is overloading? Well, because we can use these operators to compare numbers. And so what we're doing here is now we are comparing the letters, and so we are going to use some kind of rules in order to do that. I think we can all agree that the code required to compare letters would need to be distinct from the code required to compare numbers, and that is why we call that overloading. That's what overloading does. Within the same case, they are compared in alphabetical order, so less than really should be read comes before, right? That's the easier and better way to read this for the letter situation. So when we say within a particular case, we want to find out if some letter comes before. So for example, A is less than B says A comes before B in the alphabet, which is a true statement. We say all of these are going to return Booleans, right? Because we're asking the question, does A come before B? The set of uppercase letters also within the case will be a similar situation. We'll be asking the question, does A come before B? Is A less than B? And that sort of thing. Here's an example. Does Z comes after Y, which is a true statement. And so it gets a little bit more complicated when we have a mix between the uppercase letters and the lowercase letters. So really the best way to think about it is some sort of a continuous alphabetic number line here, where we have the uppercase letters coming before all of the lowercase letters in the alphabet. So then if we look at it like that, it's easier to interpret what exactly these things would mean. So the precedence is going to move from left to right when the letters are lined up as I've shown them here. And so we're going to say, does capital Z come before lowercase a? And so, of course, with that, what we need from left to right. So is Z coming before A? And the answer is yes, it is. So this is true. Now we can also do that when we have multiple letters. And so what we're going to do is compare on the first letter that differs. So in Z, capital Z, lowercase a versus lowercase a, capital Z, what we're going to do is we're going to compare on the first character. So this says capital Z precedes lowercase a, which is a true statement. So we can already decide which one comes first based on that, so that will be true. Next, let's consider ZA versus AZ in capital. So here we're going to say Z comes before capital A, right? And that is a false statement. So we can already decide based on the first character. So we designate that as false. Now let's take a look at this one. This says lowercase z comes before capital A, and that is a false statement. Here we have another example, lowercase z comes before lowercase a, false statement. So positive integers can also be compared as strings. However, this is string comparison and we need to be cognizant of how this is working. It may not be exactly as you expect. So 0 is less than 1, makes sense. But let's take a look at this. They're going to be compared as strings. So they're going to be essentially left justified, meaning that, so normally you will learn, for example, that this is 100, this is the hundreds place, right? And so that's worth more than the tens place, and 20 starts only with something in the tens place. So of course, 100 is greater than 20. But here, what we're going to do is we are going to compare place by place, being left justified. So this says 1 is less than 2. Well, I mean, so because these are being compared as the numeric version, and this is the version being compared as strings, right? So 100 is, of course, not less than 20. But if we do them as strings, that does come out as true. Now, this is because as strings, we're saying the digit 1 comes before the digit 2, and that's a true statement, and it's already different, so a distinction can be made, and so it returns true. So yeah, you just have to be very careful about how the comparison is being done, to realize that when you're doing them as strings, that it's a little different than expected. It's not based on the numeric place value, it's based on a character versus another character. So rules involving special characters such as punctuation, negative signs, decimal point, and so on also can be ordered using these but they are somewhat arbitrary, so you do not need to memorize those. If you need to know them, what you can do is you can look it up or test it with Python. Numbers should generally be compared using their proper type and not as strings. So determine if Python will return true or false. All right, so here is a little exercise for you to do. So once again, if you can pause that video and see if you can determine if these are going to be true or false. We'll see you back in a moment. All right, welcome back. Let's see how you did. String comparisons, true or false. So Huron.upper is greater than Erie.upper. So what we need to think about, what will they resolve to? So Huron and Erie in uppercase will have H comes after E, which is a true statement. So now we're going to convert superior to lowercase, and whether or not that is less than Michigan, right? So we will have lowercase s comes before capital M, which is false because all the capitals come first, no matter which letter they are. Here we have an interesting comparison where we have some things in camel case, that is they're mixed, right? And so the first position that differs between them is the capital T and the lowercase t. So this reads capital T comes before lowercase t, which is a true statement because all capitals come before lowercase. Here is another one. We're going to convert the Ontario camel case to Ontario lowercase and ask whether and say that is not equal to Ontario dot lower, and that will be a false statement. Next, we're going to do the in operator. The in operator is going to allow us to ask the question if some string is a subset of a larger string. So the in operator is going to take two strings as operands, and it will return a Boolean, true or false, depending on whether or not the left-hand operand occurs as a substring in the right operand. Otherwise, it will return false. So we're going to have some left-hand operand and the right-hand operand. So we're going to ask the question if something is inside of something else. So for example, is super in superior? So yes, it is. So it will return 2. We can also ask, does great appear in superior? And the answer is false. The in operator can also have some additional examples with some of these special cases. So a slice has to be consecutive. So sir in superior, we can see that sir in fact isn't superior, but it's not consecutive. So this is going to return false. Here we're trying to do the search and it's case sensitive. So we're on the name with the capital R and it does not appear in Huron. So in order to process that, if we wanted that to find it, we would need to convert the cases of these before we did that. It will only do a forward search. So for example, is there a rat in Ontario? Well, yes, there is, R-A-T right there, but that's spelled backwards and not forward. So that will return false, even though it's consecutive. It's because the order is incorrect. So then let us do a little word search. So write a function called word search that takes two strings, S1 and S2 as input. It's going to check if S1 is a substring of S2 and return true if it is and false otherwise. The search should be case independent. Test with on in Ontario. So go ahead and take a moment to see if you can write that function, and we will check back with the potential solution for you in a moment. So here is a potential way you could have solved this. There are a couple of ways you could have done it, but this is one way you could do it. So here I've defined my function and I've included my signature. This function has two inputs, string 1 and string 2. And here what I'm doing to make sure that these things are going to be case invariant is I am converting both string 1 and string 2 to upper and reassigning them to S1 and S2. So this is an example of where we are overriding the value of a variable as we're going through the program. So now you see what I've done is I've cleverly put this all into just a single statement, return S1 and S2. So what you might have done is you might have done S1 in S2 and that would return true or false, and you might have stored that in a variable and then returned that. This is an example of composition where I have just put that right into the return statement. So S1 and S2 will return either true or false, and then return is going to send back the true or false that they got out of evaluating the statement. So for example, is on in Ontario? That should return true because it should be case invariant, but notice that we had this problem. This is capital, but we've overcome that by converting everything to uppercase here. So this is how this will work. Next, let's talk about for loops and strings. So for loops, as you might recall from last week, is another way of looping. So for loops is very useful because it is a kind of like an automated version of while, if you will. With it, not exactly. There are a couple of things that are a little bit different, but it's a useful tool. Processing each character in a string in turn is a common task that we would need to do, and so it stands to reason that we may have some mechanism built into Python for doing this. We already saw looping with the while and a counter to do this earlier in this lecture, where we had a pointer I, and we used augmented assignment to move that pointer up to the next position, and so the pointer then would move over the entire string. The for loop is going to be a simplified structure for that. This is going to be the for loop, and the way in which it's going to be simplified is in that it automatically advances the pointer for you. This will automatically assign each character of the string in the loop to a variable, and that in turn will cycle over the loop body. So here what we have is for a loop variable in string. So here you're going to put some variable name, some kind, and this is basically equivalent to the I that we've been using before for the index. Then you're going to have your loop body, whatever you want to do for each character in your string. So for example, a very simple for loop would be for character in Erie. Okay, so character is a really good variable to use for your loop variable name. Now you don't have to choose that variable name, but it is a prudent choice because it will help you remember what it is we meant by that. So we say for character in Erie, print the character. Very simple loop. So here we have it. It will cycle over Erie, and what will happen is first there'll be the loop variable, the first character, will be equal to E. And now it says print character, so it will print the capital E. Then automatically it moves to the next position as it goes back to the top of the loop. And now it's pointing to the R. So character is equal to R, and we're going to print the character, and the R gets printed. Then automatically it moves forward to the I and the E in turn and prints each of those out. So here's an example of a for loop for counting some vowels. What we'd like you to do is to write a function that will count how many vowels are present in some input string S. Then what we are going to do is process the string using a for loop. Call another function, isVowel, to determine if each letter in S is a vowel or not. So how can you tell if something is a vowel? Is there anything that we've learned so far that would help you search some finite list to know if it is a vowel? This should be case independent. If it is, we should increment an accumulator count to keep track of how many vowels you've found so far. And then we're going to increment the accumulator so that we're going to continue, and then we're going to assume that the vowels also are A, E, I, O, and U. All right, so this is actually a bit of a complicated question. This is a really great question to prep you for your exam, because these are the kinds of things we might ask you to do. Putting a couple of different concepts together and challenging you to come up with or to synthesize some new function based on the various parts that we've learned so far. So take a moment to see if you can solve this, and then we will check back. So here is a possible solution for this. Now, again, there's many ways that you may have coded this up. So this just simply represents one of the possible ways that this could have been done. So notice that I have two functions here. I have isVowel, and I have my count vowels function here. And so the isVowel is going to do something quite useful. It's going to return true or false to tell us whether or not a vowel has been encountered. So in order to do this, and what I was trying to hint at earlier, we may wish to use the in method or function in order to do this. So we can just do character dot lower in AEIOU. So that is basically all the possible vowels that we're considering, and we're going to ask the question, is the character that we're on in this AEIOU? And if it is, it will return true. So that suggests that what we might do is we might have some kind of a function, right, that might be then calling this function to use the output of this. And if it is true that it is that the current letter is in AEIOU, that we would take an action such as incrementing a counter. So let's see how exactly this is going to work. So in our count vowels of string, what we're going to do is set our counter to 0 to represent having encountered no vowel so far. Then we're going to use a for loop to loop over that string. So for character in string, if the is vowel of character, so here what we're doing is we're calling the is vowel function right here, and we're sending up the current character in the string. What we're going to do is if this returns true, right? So if is vowel means what is this resolving to? And do you see that this is going to return a Boolean, which we've indicated with our signature right here. So if this in fact returns true, then these actions will happen. Count will be incremented by 1. If it is false, that is, it's not an AEIOU, this will evaluate the false, and because the branch guard is false, then the branch will never actually run. So this is going to then cycle over all possible characters because this is a for loop, and when it reaches the end, then it will get to this line here, return count, and because count has been incremented each time a particular situation was met, then we will arrive at the running total of the number of vowels in the input. So here is an example. We're going to count the number of vowels in Erie, and there are in fact 3 vowels in Erie. Something that's very useful to understand how to do is to interconvert a while and a for loop. Oftentimes there will be a preference of how you would write looping, but it is generally possible to convert between the 2 types. So what we're asking you to do here is to rewrite this while loop using a for loop instead. So here's a while loop. So count S. So what this is going to do is it's going to count the number of S's in a river name. So we have worked with this earlier. And so what we would like to do is convert this to a for loop. So think about how is it that you would go about doing that. We would probably be setting up some kind of a for loop to process over a particular river's name. So here is a comparison side by side of a while loop and a for loop. So this is the one we've been working with thus far, and here is how we can set it up for a for loop. So similar to the situation on the left in the while loop, we have the counts being equal to 0 in the beginning, and then we're going to have some looping, and we will return counts, which will accumulate the number of vowels or number S's in rivers. And so in that regard, they are similar. However, notice that on the left in the while loop, having I equals 0 is required, whereas in this case, using the for loop, having I equal to 0 to get started is not required, because the I is in fact actually going to represent each of the positions in the river, whereas on the left, the I will be a type of integer and will be a slice, right? So here we're going to have to deal with a particular position. So we're going to either use indexing or slicing to pull something out. Here we are going to just be using the indexing to pull out a particular position in the river, whereas pulling out a particular position is happening automatically in the for loop. So this is what we needed to do. We need to set up our for loop. So we've chosen to do for I and river. We could have also chosen for character and river, which may have been a better choice. But in any case, the idea is we need to have something that is cycling over the river. If I is equal to S, this is our condition. of pulling out a particular position. So notice that in this case on the left, we needed to use the indexing operator because I is not representing an actual letter, whereas in this case, I represents a letter. So if the river of I is equal to S, that is if that letter in Mississippi or whatever river we're processing is equal to S, then we need to increment the counts. Here, the I will actually be the letter, and so we can do the comparison directly, and if it matches to S, then we can increment the counts. This while loop requires incrementing the I, which is the position that is moving along the loop, and so here we see that we've incremented that by 1, whereas in this case, the loop as it returns up to the 4 and cycles through again does not require explicit incrementation of the position because, first of all, it is directly equal to the letter that it's representing, so it's not numeric, whereas in this case it is numeric. And it happens automatically. That is what for loops do. So we see that we can set up these loops either of these ways. And here is the illustration of running each of these codes and getting the same answer. All right, well, that brings us to our summary of what we have done today. This is quite a lot of information, hopefully somewhat of a review, and also this is an excellent lesson in how we can integrate that information together. So we have recalled information on strings from the previous lectures, and we have talked about built-in string methods that are available for us to use. We've looked at some ones that will actually convert between lower and uppercase, and we've also looked at the ones that are going to be giving back the Boolean information. Is alpha, is so on, right, to answer true or false, whether or not it's that particular thing. We've also looked at indexes, so we use these square brackets in order to pull out a particular position. The index and slice are related because they both pull out a piece of the string. Index pulls out a particular single position, and a slice will allow you to pull out a range. Slice starts at the beginning and ends at the end if nothing in particular is specified, but generally speaking, we would indicate a start and stop separated by the colon. We talked about while loops to iterate over strings using that. We've talked about what is required for a while loop. So the basic syntax of a while loop will require you to initialize a variable and will generally involve some kind of a counter inside the loop in order to cycle over it. We've compared strings, so using the less than, greater than, and so on, again, to get a Boolean. We remember that we have the capital letters occurring before the lowercase letters, and otherwise we are just asking the question, does something precede something else in the order of the alphabet? We've used in operator to check if there's a substring within a larger string. This again will also return a true or false Boolean value. We've looked at for loops and compared and contrast them to the while loop. This is used to cycle over loops when knowing which position you need to look at is not necessary. So if you do not need to know the numeric value of a certain position, you could use a for loop, which is more succinct than using the while loops. Finally, we've put all of these things together. We've combined new string skills with flow control and functions to write brief programs. So that concludes the material that will be covered on your exam 1. I hope you have enjoyed learning about Python. I will mention that the skills that we've learned up to this point are a complete programming language. You could, in fact, program just only with the tools that we've learned up to this point. So that is already an accomplishment. We'll be moving on in the second half of the semester to learn some perhaps more advanced topics that will basically be shortcuts for the things that we've learned how to do thus far, and to also expand the functionality of Python. Looking ahead, you should make sure, oh yes, your exam is on Thursday, not Tuesday. We should be preparing for the exam. You should report to the lab section as usual. You'll be having your homework 5, which we can take up until after your exam to make sure you can focus on studying for your exam. Be working on your proposal worksheet, and make sure you reach out to us in the TA help sessions or the office hours should you have any questions. All right, thanks so much for joining us today. That concludes our lesson, and I look forward to seeing you next time to learn about lists. Bye. Bye-bye.